Welcome to our next session of Geometry Flipped Classroom with me, your instructor. Our session for today is entitled Parallel Lines in the Transversal Line. We are going to learn what a transversal line is and the set of angle pairs. Again, we were going to learn transversal line, corresponding angles, the alternate interior angles, as well as alternate exterior angles, same side interior angles, and the same side exterior angles. Aside from this, we need to learn their special relationships through the corresponding angle postulate, alternate interior angle theorem, the alternate exterior angle theorem, same side interior angle theorem, and the same side exterior angle theorem. Take note that 4 of these are theorems, and we need to prove them before accepted as true. Let us have a sort of review on parallel lines. We know that parallel lines are two coplanar lines that do not intersect, such as line L and line M here. We say that line L is parallel to line M. In symbolic form, it stands this way. This is the symbol for parallel lines. Again, this is the symbol for parallel lines, and take note of that because it's very important for the next part of this session. Transversal line. Let's talk about these lines. Line C is a transversal line. In the next figure, line N is also a transversal line. And in this last figure, line W is also considered as a transversal line. In 20 seconds, I want you to define what a transversal line is. You may start. You have 5 seconds left. Time is up. Now, what do you think a transversal line is? Take a look at C, N, and W. As you can see, they have the similar concept that these lines intersect 2 or more lines in different points. Let's take a note of this one. In this figure, the inside is called interior and the outside parts are also called exterior. Again, the inside is the interior and the outside is the exterior. Let's start with the first angle pair. Our first angle pair, when a transversal line cuts 2 different lines, is called the corresponding angles. Consider this figure, we come up with a different angles here. Actually, there are 8 angles formed if a transversal cut 2 different lines. Let us label them from angles 1 to angle 8. In this figure, angle 1 and angle 5 are considered as corresponding angles. However, angle 1 and angle 3 are not. As well as angle 1 and angle 7, they are not corresponding angles. And lastly, angle 1 and angle 6 are also non-corresponding angles. In 20 seconds, please define corresponding angles. Do you have any idea? Okay, time is up. Now look at angle 1 and angle 5. They have the special relationship. First, what made angle 1 and angle 3 non-corresponding? Because corresponding angles must be a pair of non-adjacent. Angle 1 and angle 7 are also non-corresponding because corresponding angles must be or must have one interior, as angle 5 shows, and the other one is also an exterior. Aside from this one, they must be on the same side of the transversal line. That's what makes angle 1 and angle 6 non-corresponding. Aside from this, we also have angle 2 and angle 6 as corresponding angles, angle 3 and angle 7, and lastly, we have also angle 4 and angle 8. Aside from corresponding angles, the second pair of angles here are named as alternate interior angles. In this given figure, it is said that we have a pair of alternate interior angles in the name of angle 4 and angle 5. If this is true, we also have a pair here that is not alternate interior angles. We have angle 3 and angle 4, as well as angle 4 and angle 8. And at the same time, angle 4 and angle 6 are also not alternate interior angles. I want you to define alternate interior angles in your own words. Go. Time is up. Now, when you look at angle 4 and angle 5, it's already in the given definition. What makes them alternate interior angles is that they must be still non-adjacent. 3 and 4 are adjacent, therefore they are wrong. Aside from that, what makes 4 and 8 wrong? Because we said that they must be interior angles. And therefore, both of them must be interior angles. And they must be on the opposite sides of the transversal line. Aside from this pair, do we still have one more pair? Yes, we have angle 3 and angle 6. The next pair of angles is actually named as alternate exterior angles. We also have a pair here of alternate exterior angles, which are angle 1 and angle 8. If they are true, we also have non-alternate exterior angles here, such as 1 and 2. We also have angles 1 and 5. And lastly, we also have angles 1 and 7. These are non-alternate exterior. Please define alternate exterior angles. Go. Time is up. Okay. What makes angle 1 and angle 8 alternate exterior? Well, similarly to the concept of alternate interior, it just so happened that they are just on the exterior part. Therefore, they must be a pair of non-adjacent angles found on, yes, because they are exterior, they must be found on the exterior part, or they are both exterior angles and on the opposite sides of the transversal line, because we said alternate. Aside from this pair, another pair is here. We have angle 2 and angle 7. Let's proceed to the fourth pair of angles here. We have the same side interior angles. In this figure, the same side interior angles are given as angle 3 and angle 5. With this, I want to define later on what are same side interior angles. Additional information, angle 3 and 4 are not, angles 3 and angle 7 are not, and angles 3 and angle 6 are not. Define same side interior angles, please. Okay, time is up. What makes angle 3 and angle 5 same side interior angles? It's already there. Look at the name itself. You can actually have a definition on that. They must be a pair, again, of non-adjacent, because 3 and 4 are not. At the same time, they must be, yes, they must be both found on the interior, and when we say same side, they are on the same side of the transversal line. Aside from angles 3 and angle 5, we also have one more. The angles? Yes, 4 and angle 6. Let's proceed to the last pair of angles here. We name them as same side exterior angles. In this figure, we can say that angles 2 and angle 8 are considered as same side exterior angles. If this is true, angle 2 and angle 1 are not, as well as angle 2 and angle 6. And finally, angle 2 and angle 7 are also not. With this information, define same side exterior angles. Go. Time is up. All right. Yes, you're right. Same side exterior angles, from the name itself, must be a pair of non-adjacent. That's what makes angle 1 and angle 2 incorrect. And it's already in the name itself, a pair of non-adjacent. We say exterior. Yes, that's correct. Both found on the exterior. By the way, that's exterior, on the same side of the transversal line. Again, that's exterior. That is the case. We also, another pair here, angle 1 and angle 7. Sorry for the clerical error. So if we have these 5 pairs of angles here, we also have a special relationship for them. But take note, these special relationships here are only true if L is parallel to M. I repeat, if L is parallel to M. If they are not parallel, this corresponding angles postulate is not true. It states that if a transversal cuts parallel lines, then the corresponding angles are congruent or have the same measurement, such as angle 1 and angle 5. If this is really true, if we say that the measurement of angle 1 is 70 degrees, we need to show that measurement of angle 5 is something else. Let's find out the proof of this one. I want you to prove this postulate before we will accept it as true. Your time is ticking. Okay, time is up. Well, of course, this is a postulate. Again, postulate are statements that is accepted true without proof. So we are going to say that this is now accepted as true. We say that a measurement of angle 5 is also 70 degrees because they must be congruent. Again, only if they are parallel. Okay? If you found another pair of corresponding angles, they must be congruent because of the postulate. The second relationship is for the alternate interior angles, or specifically alternate interior angle theorem. It states that if a transversal cuts parallel lines, again, parallel lines, then the alternate interior angles are congruent or has the same measurement. Let's say angle 4 and angle 5 here. If we're going to say that the measurement of angle 4 is 80 degrees, we need to show that the measurement of angle 5 is also 80 degrees, or they are congruent. But this is a theorem. Please analyze and prove this first before we say that this is true. How do we show that measurement of angle 5 is also 80 degrees? What do you think? Okay, time is up. Well, actually, we can say that if the measurement of angle 4 is 80 degrees, we can come up with another relationship here, and we can say that a measurement of a specific angle, which is considered as angle 8, is also 80 degrees, because they are corresponding angles, and we have a corresponding angle postulate earlier. If this is the case, look at the relationship between angle 5 and angle 8. They are considered as vertical angles, and therefore it must also be 80 degrees. This is the proof that a measurement of angle 4 and measurement of angle 5 are just the same. We already proved this theorem. If you see another pair of alternate interior angle for parallel only, again, if parallel only, the next relationship falls for the alternate exterior angle theorem. This is only for alternate exterior angles. This states that if a transversal cuts parallel lines, then the alternate exterior angles are congruent or have the same measurement. We have angles 1 and angle 8 here. If we say that the measurement of angle 1 is probably 65 degrees, we need to show that the measurement of angle 8 is also 65 degrees for this theorem to be accepted. Let's analyze it for 20 seconds. How could we show that the measurement of angle 1 and measurement of angle 8 are the same? You may use anything you have learned so far. Time is up. Well, actually, you can have angles here using the corresponding angles postulate. We accept it as true because that is postulate, and therefore they must have the same measurement, such as the measurement of angle 1 and measurement of angle 5. Angles 1 and 5 are corresponding angles, therefore they must have the same measurement. And then again, angle 5 and angle 8 are vertical angles, and they must be also similar in measurement. This means that the measurement of angle 1 is just similar to the measurement of angle 8, which is 65 degrees. This is the proof for this theorem. But again, this only works if they are parallel. Kung hindi, hindi pwede rin. Let's have the next relationship here that works only for same side interior angles. For same side interior angle theorem, if a transversal cuts parallel lines, then the same side interior angles are now not congruent but supplementary, or in short, they sum up to 180 degrees, such as angle 3 and angle 5. So if we are going to say that measurement of angle 3 is 110 degrees, we need to show that the measurement of angle 5 is something that is a supplement of 110 degrees. How do we show that this is true? Time is up. Well, as you can see, we can also use corresponding angles postulate here, or any other theorem. If measurement of angle 3 is 110 degrees, we can say that a specific angle, such as angle 7, is also 110 degrees because of corresponding angles postulate. And take a look at angle 5 and angle 7. They are forming a linear pair, and therefore they must be supplementary, and the measurement of angle 5 must be 70 degrees. Look at angle 3 and angle 5. If you're going to add up their measurements, they add up to 180 degrees. Again, this only works for parallel lines. Therefore, they are supplementary. And lastly, the last theorem we need to learn is named as same side exterior angle theorem. The same side exterior angle theorem tells us that if a transversal cuts parallel lines, then the same side exterior angles are considered as supplementary, or they side up to 180 degrees, such as angle 2 and angle 8 here. Need to show this first before accepted as true again. Now, if we assume that the measurement of angle 2 is 100 degrees, we need to show a specific measurement for angle 8 that makes them supplementary. Let's have 20 seconds for that. Time is up. Now, again, similarly, we can come up here with a relationship using the corresponding angles postulate because the lines L and M are parallel. Then we can say that the measurement of angle 2 is 100 degrees. Measurement of angle 6 is also 100 degrees because they are corresponding angles. And angle 6 and angle 8 form a linear pair, and they must be supplementary, and therefore angle 8 must be 80 degrees. This is a proof of this theorem, leaving measurement of angle 2 and measurement of angle 8 sums up to 180 degrees, or they are in short, supplementary. Again, this only works if they are parallel lines. Now, these are the key terms you need to remember and you need to review from time to time. You can use this video as your help. Again, do not be afraid to review this video and to watch it all over again for your own benefit. These are the terms. We have the 5 pairs of angles and the transversal line. Aside from this one, we also have the 5 relationships here, the apostolate and the 4 theorems. If you were able to view this video, just simply comment your complete initials on the comment section of Schoology. Such as me, I am LLBS. Okay, our next meeting is entitled Polygons. Thank you very much for watching, and hopefully you have enjoyed our session 4.